Swayam Prabha. Digital India. Educated India.
So, in my previous lecture, I discussed about how to get the earth pressure, active earth pressure under static condition using Coulomb's theory. Now, I discuss that if I incorporate the pseudostatic forces, so under seismic condition, then how I will get the active earth pressure. So, and that approach is the Mononobe-Okabe approach, Okabe theory, which is the extension of the Coulomb theory, and then where it is a pseudostatic analysis. So, you know this is a pseudostatic analysis. Pseudostatic analysis, where these two forces, the horizontal force kh into w and the vertical force kv into w will introduce. And as I mentioned during my slope stability analysis also, that generally the sometimes this kv is been neglected because the effect of kh has significant effect as compared to the kv. But in the kh has the significant effect as compared to the kh, but it doesn't mean that the kv doesn't have any effect, but you can also consider the kv in the analysis, but sometimes we will consider the kv as 0. So, now if these two forces are applied and then same these forces are represented in this form, and then if we analyze like we did for the Coulomb's theory, then we will finally get the expression of the PAE. So, now that expression of PAE is given as half into gamma into h square into 1 minus kv into KAE. So, that is in the PAE, it is not the seismic, it is static plus seismic, and only static, that is PA, that I have discussed in the last class, the gamma into h square into Ka, that is only static. So, my seismic component PAE, so this is the seismic component. Of the force, that will be equal to PAE minus PA. Clear? Similarly, I can write that PPE, that means this is passive, this is for active, this is for passive. Okay. So, this is your P means passive, A means active. So, this will be the similar expression, half gamma h square 1 minus kv into KPE, and for the static PP is equal to half gamma h square into Kp. Clear? Now, here when I am talking about these two equations, so you can see now the expression I am giving. So, these are the expressions of your Ka, Kae, Kp, Kpe. What is Ka? It is the active earth pressure coefficient under static condition, or you should say static earth pressure coefficient, and KAP AE, that means the seismic active earth pressure coefficient. Then KP, the static passive earth pressure coefficient, and KPE, seismic passive earth pressure coefficient. Clear? So these are the equations. So meaning of this thing, phi, you know, friction angle of the soil. Beta is what? Beta is this angle. This, the wall is making with vertical. So this is the beta angle. Then the delta is the friction angle between the soil and the wall, and phi is the friction angle in the soil. That means phi is the soil to soil friction angle, and for delta is the soil to the wall. Okay, and your I is this angle. The backfill is making with the horizontal. If it is horizontal backfill, then I will be equal to 0. For inclined backfill, this I should have some value. And then, so that's it, these are the meanings. So you can see there is a extra term is added in the seismic components, not in the static, that is called theta. What is theta? Theta is this expression. Theta will be tan inverse kh by 1 minus kV. So theta is tan inverse kh 1 by kV. Now if you look at these expressions, so here if you see that if I right now I am talking about the active, because the passive is the same, similar to the active also. If I discuss these things in the active, so that can be also applicable for the passive in a similar way. So that's why I am given you the passive expression, but in most of my analysis, rest of the analysis or discussion will be related to passive only. Okay, but you know that this related to the active only, but the passive expressions are also given. But the next most of the discussion will be related to active force only or active condition only. Now if you look at these two equations, Ka and Kae, so you will find that when I will not get any solution, when it is possible, it is been possible if I will get a negative value within the root. Okay, if I get a negative value within the root, so then the solution is not possible. So in the first case, is it possible to get a negative value within the root? That, and what are the possibilities? The possibility is only that if your sine minus say x, that will be minus sine x. So and it is only possible if your sine is minus, sine part is minus, and if I get to Ka, then here it is phi minus I. Now the phi minus I, it is impossible that I would be greater than phi, and then that is solution is not possible here. That means it is quite obvious that your slope angle will not be greater than phi. But if it is greater than phi, you will find that it will be sine will be negative and you will not get any solution. So that is static part, that is the condition. Similarly, in the seismic part also I will get this condition that if that condition that my if that phi here phi minus theta minus I less than 0 from here. Okay, then no real solution of Kae is possible. No Kae is possible. Clear? You can see. So now if I put, so that means that the condition of that getting that the equilibrium condition will not exist. That means here. That means you can write that to get a solution or possible solution, the condition is phi minus theta minus I should be equal to greater than equal to 0. Then only a real solution is possible. So that means here, if your theta if your theta is equal to 0, if your theta is equal to 0, that means no earthquake loading. No earthquake condition. Now for stability, what would be the condition? That if theta is equal to 0, that means phi minus I, that should be greater than equal to 0. So I can write that I should be less than equal to phi. So that is for the condition for stability. Okay. So that I mentioned that for the static condition, the stability should be I less than equal to phi. Now if I put that I is equal to 0, okay. So if I put I is equal to 0, now I can, then in that condition your phi minus theta should be greater than equal to 0, or the condition is theta should be less than equal to phi. So that is for the condition for stability. So this is the condition. Now I am putting I equal to 0. That means a horizontal backfill for simplicity. So if your inclined backfill, then also you can put the I here and you will get similar type of condition. Here I put I equal to 0 and I will get theta less than equal to phi for the stability condition. Okay, so now I know that theta is equal to tan inverse kh 1 minus kv. Okay, and now if I take the tan in both sides, so I can write that tan theta will be equal to kh 1 minus kv. Clear? And for this stability condition, I can write that tan theta should be less than equal to tan phi. That is the stability condition. So if I put tan theta here, my kh 1 minus kv, that should be less than equal to tan phi. Okay. So, or I can write that kh, that should be less than equal to 1 minus kv into tan phi. Okay. So that means here kh should be less than equal to 1 minus kv into tan phi. So before the starting the analysis or calculating your active force under seismic condition, you check first whether the stability condition can be achieved or not. So that means it has a kh as a critical value. So that kh critical, that is equal to 1 minus kv into tan phi. So that you can check for any if we do the analysis, then if your k that you are using in the analysis is greater than k critical or kh critical, if your kh value is greater than kh critical, then you will not get any solution. That means that it is not a stable condition. So for stable condition or for the condition for stability, your kh critical or your kh value must be less than the kh critical or equal to that. Clear? So now if your kv value is 0, then your kh critical will be simple tan phi. if your kV value is 0. So, this you should remember this thing before the starting of this your any analysis. Now, we are talking about that. Now, this is del PAE and del PE. Okay. Now, what would be the point of application? Because I know the PA will act at a height of h by 3, but where the PA will act? Will it act at h by 3? It's not. The condition is that how I will calculate the your point of application. For example, this is the retaining wall. So, suppose this is your PA will act here. This is the 90-degree line. So, this PA will act at angle of delta. Now, this height is h by 3. What is h? H is the height of the retaining wall. Clear? But your seismic component, that will not act at h by 3. So, this is 90-degree. So, this is again delta. So, this is del PAE. So, that is only the seismic component, and that will act at a height of 0.6h. So, that means this is only seismic component part. So, that will act as a height of 0.6h. Now, the overall del PAE, where the PAE will act. Now, my point of application, the point of application of PAE. So, this is the point of application of PAE. That means the static plus seismic. So, that will be equal to from the base. From the base. That will be equal to, very simple, that PA into h by 3 plus del PAE into 0.6h static plus seismic, and that will be in between. This is h by 3 to 0.6h. Okay. So, that will be say sometimes maybe here. Okay. And this value is actually h bar. Clear? So, that means here I will get the value of h bar. So, now I will solve one example problem, and then I will show you how I can calculate this PAE, del PAE, del PAE, and then from there the height of or the point of application of PAE. So, example that if your beta is equal to 0, I is equal to 0, that means the beta 0 means perfectly vertical wall, I is 0 means horizontal backfill, and phi friction angle is 35 degree, delta is equal to 20 degree, height of the wall is 6 meter, then unit weight of the backfill soil is 18 kilonewton per meter cube, then KH is 0.25, KV is equal to 0.1, then determine the active force of the wall. Okay. And point of application of PAE, obviously from the base. Okay. So first I will calculate the Ka because that is required. So this is the expression of Ka. Okay. So I am putting these values. I am putting this value that here your Ka expression, this is cos square, your phi minus beta. Phi is 35 degree, beta is equal to 0. Then cos square beta, again cos square beta, beta is equal to 0. Then cos delta plus beta, delta is how much? 20 degree, again beta is equal to 0. Then 1 plus root over your sine 35, sine phi plus delta, phi is 35 degree, delta is 20 degree, and sine your phi minus I, phi is 35 degree, I is equal to 0, divided by cos delta plus beta, delta is equal to 20 degree, beta equal to 0 degree, into cos I minus beta. So 0 degree minus 0 degree, and cos 0 equal to 1. So that is whole square. So if I put that, these values, and I will get it is 0.245. Again, before that, I have to check whether the stability is possible or not, or the solution is possible or not. So you know that already the condition that K critical or KH critical, that is equal to 1 minus KV into tan phi. Okay. Now this is 1 minus KV is equal to 0.1, tan phi is equal to 35 degree. So that value is equal to 0.63. So which is greater than 0.25. So it is okay. So that means the solution is possible and it is a stable slope, because K critical is greater than 0.63. Sorry, K critical is 0.63, we have taken a KH value of 0.25. So next step, that I will calculate the KAE. To calculate that, I have to calculate the theta value. What is theta? Theta is equal to KH divided by 1 minus KV. So here tan inverse KH is 0.25, then 1 minus 0.1. So this angle is 15.52 degree. Okay, theta is 15.52 degree. Now I will calculate the KAE. So this is cos square phi 35 degree minus theta 15.52 degree, then minus beta, beta is 0 degree. Okay, then it is cos theta. Cos theta is cos 15.52 degree, and into cos beta, which is cos 0, I can write 1, then cos delta plus beta plus theta. So cos delta is 20 degree, beta is equal to 0, theta will be 15.52 degree. Okay, so into 1 plus root over, so within root it is sine phi plus delta. So again phi is 35 degree plus delta is 20 degree, again sine phi 35 degree minus theta 15.52 degree minus I is 0 degree. Okay, then cos delta plus beta plus theta. Delta is 20 degree, beta is 0 degree, plus 15.52 degree is the cos. Then cos I minus beta, I is 0 degree and again beta is 0 degree, that will be equal to 1. So from here the value of KAE is coming out to be 0.45. 0.45. So now I can calculate the PAE, that is equal to half into gamma into A square into 1 minus KV into KAE. So it is half, unit weight is 18, unit weight is 18. So unit weight is 18 into H square is 6 square, because your height is given, H is given 6 meter. So 6 square, 1 minus 0.1, kV is 0.1, KAE is 0.45. So that is equal to 131.22 kilonewton per meter. Similarly, I can calculate PA, which is half gamma A square Ka. So half into 18 into 6 square into Ka is 0.245. 0.245. Clear? So it is coming out to be 79.38 kilonewton per meter. So total is 131.22 kilonewton per meter. Out of that value, 79.38 is the due to the static force. And now so del PAE, only the seismic component is PAE minus PA. So this is 131.22 minus 79.38. So that will be 51.84. So now I have calculated the total force, including seismic plus static. Then separately I have also calculated the static force and the seismic component of this active force. Now I have to calculate the point of application. So H bar, that is from the base, so that is your PA into H by 3 plus del PAE into 0.6 H divided by PAE. So PA is how much? PA is 79.38 into 6 by 3 plus 51.84 into 0.6 into 6 into PA is 131.22. So that will be 2.63 meter from the base. So this way we can calculate the active earth pressure or active force for static condition, seismic plus static condition, and then we can calculate where the resultant force, considering seismic and static, will act from the base. Okay, so by using this pseudostatic approach. So in the next class I will discuss about the pseudodynamic approach, where this time effect will be incorporated, and then I will discuss that if the water table will present within the backfill, because here I have not considered any water table effect. So if the water is present within the backfill, then what will happen and what are the forces will come, because those are very important for waterfront retaining structure, where you have to consider the effect of water within the backfill and the free side also. So those things, what are the forces will come, those will be discussed in my next class. Thank you.